So now we've been through 6 lectures on deep learning, and it's maybe a good time now to make a little bit of status. And you can ask, first of all, how does these methods scale? And why not ask Joaquin here, who is the director of applied machine learning at Facebook, and by the way also a DTU PhD. So it's nice to see that you can make it in the world as DTU PhD. And of course we know all about what Facebook is doing, but it's also interesting to get some numbers on how much do they actually do every day. So in computer vision, for example, you heard a lot about their algorithms that they censor, for example, nudity, and maybe censor sometimes some important historical photographs, including nudity. But they have computer systems that classify 1 billion images per day. You can also see Joaquin likes these 1B, 2B, and so on shorthands to kind of give an impression of the scale. Also in language technology, they translate 2 billion posts every single day, and they translate automatically between 40 different languages, so that gives like 1800 different language directions that they apply. They also, and maybe this is the most important role of machine learning, they also rank your feed, and every user has something like 1.5 thousand stories per day to be ranked. So that is a lot of power here a lot of computing power is involved in this. But this is doable. Facebook can pull this off, and computers get faster and faster, so probably this is just the beginning of what they will do with your data. So remember this Venn diagram from the beginning of the course, where we can see data science in the sweet spot. What I hope we have achieved in this course is to give the participants both a little bit more on the math and modeling circle, because you have now gotten a new set of models in your toolbox, statistical models, deep learning statistical models, and probably, hopefully, you also learned something about computing with deep learning libraries, and hopefully you have also witnessed yourself some of the complications of working with kind of new frameworks. So I'm almost reached the end. So let me make a few predictions about the future. So this graphs from NVIDIA gives hope or fear, depending on who you are, that this progress we have seen in computing and in deep learning will continue for some time on, because this shows an estimate of the speed, or rather it's not the speed, but it's the number of flops per watt. So it means the number of computations per energy unit consumed as a function of the different generations of their GPUs. And you can see that they have just introduced this Pascal architecture this year, and you can see it has given like a threefold or something like that increase in the energy efficiency. So this means that that from the computational point of view, we can expect to see a lot of progress still in deep learning. And also I think there's a lot of intellectual power going into this from universities and big companies like Google. So we'll see a lot of really extraordinary new systems built on deep learning coming out in the coming years. But it's, as you all also know by now, it's challenging to make these things work. So sometimes it can feel like how this guy is working with these blinds. This is how frustrating it can be to learn to get deep learning to work. But I hope that we have achieved gone some way towards having you master the trade of deep learning, so you will not end up tearing your blinds like this guy. So that's all I wanted to say. Thank you for listening.